Dynamic equilibrium, part 2. So we look at the first segment dealt with what is dynamic equilibrium. The second segment looks at measuring something in terms of equilibrium. And it's referred to as the equilibrium constant. And it'll tell us what reaction is favored and what exactly happens at equilibrium. So if I have a hypothetical equation here, two A gas molecules, two B gas molecules in equilibrium with one C gas molecule and one D gas molecule. To write a mathematical expression for that or equation, it's referred to as KEQ, or equilibrium constant. And it's a ratio of what we have finally compared to what we have initially, or products over reactants. You know, in your textbook it's stated in words, each raised to the coefficient, exponent, but you can really see it just from this example that we write our products over our reactants, and if there is a coefficient in front of each species, that gets raised up to be the exponent. So C to the 1, D to the 4, all over A to the 2, and B to the 3. So it's just a way of relating products to reactants. So those coefficients become exponents. So that's as simple as that. That's the equilibrium constant. Okay? And what that does, what it tells us, first of all, the value of this KEQ gives you an idea of the concentrations of the reactants and products at equilibrium at certain temperatures and pressure conditions. So you will see tabulated results of KEQ values pertaining to particular equations taken at certain temperature and pressure conditions. Also, you will find that it can also give you information that it can inform you if a particular reaction is useful in making a product. If I wanted to make, for example, if I wanted to make some C and D, should this be the reaction I use? Would I get enough being produced at equilibrium? That expression can help me find that. And it can help me find that by simply looking at the value of KEQ. If I get a large value for KEQ, that must mean I have a lot of products over a small amount of reactants, so I would say products are favored there. If KEQ is in between 0 and 1, that means I have a small product value over a large reactant value, so that means I have more reactants. Reactants are favored in that reaction. So those values can help you decide whether a reaction is favorable to make a certain product. And also KEQ values result from concentration of reactants and products at equilibrium only. So we're talking about comparing products to reactants at equilibrium, when that plateau line has reached on that concentration versus time graph. That's when we're looking at the KEQ value. Okay, so just another example here. I think it's from your textbook. Write the equilibrium constant equation for the following reaction. So we have two sulfur trioxide gas molecules, one CO2 gas, in equilibrium with CS2 gas and 4O2 gas. So once again, KEQ, products over reactants. If there are coefficients, that species gets raised to that equal number as an exponent. So solution here, if we look, quite easily KEQ equals, products over reactants, so that's CS2 multiplied by the concentration of O2, but it's a 4 because I have that 4 in front, SO3 to the 2, and CO2. Easy. Very easy stuff there. Simply writing down the equilibrium equation. A couple of things to note there in the final here with this segment. Notice in the example that all species are in the gas phase in this particular one. If they are all in the same phase, that is referred to as a homogeneous equilibrium. So all in the same phase. If I had different phases in there, that is referred to as a heterogeneous equilibrium condition. Okay, so if they're all in the same, so that's one thing to look for especially. And lastly, solid, if you do have solid and liquid phase species, we omit them from the equation because we assume those are pure substances. Their concentration is equivalent to their density, so we don't include those in the expression. So liquids and solids simply get omitted from there. So lastly here, if I have an example of that, let's say I have this 2 sodium bicarbonate solid in equilibrium with sodium carbonate solid and water vapor and carbon dioxide vapor. The equilibrium expression would simply be that. So products over reactants. So I don't include this product because it's a solid. So all I'll include is H2O multiplied by CO2 over reactants. But the reactant is a solid, so I don't include that. Okay? So that's the equilibrium expression.